Hello everyone, welcome back to my JEE Physics channel, and we are continuing the IIT Kanpur sample paper, and this is section 2 which is more than one option questions. Okay, so let us go with the first question. So in this question they have given the force. Okay, so if you observe this, the force expression has given with a variable x component, whereas y component is constant. They have given the mass and particle is starting initially at rest, initial velocity is 0, particle is starting from origin, and they have given alpha and beta values also. They have given angular momentum of torque, they are asking about origin. See, whenever you are finding the angular momentum or torque, about reference point or axis is very important. So with respect to origin, angular momentum and torque they are asking. Okay, so usual notations. The first option is saying torque about a point. Okay, I mean torque about origin at this point when particle is reaching to this point. So similarly, angular momentum also given, displacement of particle they are asking, and velocity of the particle they are asking. So ultimately we require the first displacement and velocity, because if I know the displacement and velocity, then I can go for angular momentum. So as I know already force value, if particle is at this position, okay, so let us see that how to identify the torque one by one. Okay, so first we will analyze the whatever given force is there. So what is the force value is given? The force value is given as alpha t I cap plus beta j cap. That means 2t I cap plus beta value is 1, simply j cap. So from this I can write down that acceleration along the x, force along the x axis by mass. Okay, then acceleration along the x we got 2t, and what is the acceleration along the y? It is simply 1, which is a constant acceleration. Okay, 1 by 1. If you want component of force is 1 and even mass also 1 kg, so it is 1 meter per second square if you want to write down with units. So simply I got ax and ay. So as ax value we got 2t, I can write down dvx by dt is equal to 2t, then dvx is equal to 2t dt. See, while integrating always concentrate on the limits, time value 0 to t, and as particle is starting from 0, initial x component is 0, so after some time x component is vx, then vx can be written as dvx is, I think you might know the integration by this time. Okay, 2 into t square by 2. Okay, so I'm solving little faster for mathematics, so maybe I think so. Okay, so if you have any issue you can revisit or re-watch the video. Okay, so then I got vx is t square, so velocity along the x is t square. So further what we do is we will integrate this to find out the position. So then I can write down dx is equal to t square dt, then integrate on both sides. 0 to x, again I am taking the y 0 because initially particle starting from origin, so 0 to t, then x minus 0 is equal to, this is t cube by 3, 0 to t, then x is equal to t cube by 3. Okay, this is the x coordinate after some time t. This is all along the x axis. Let us go with along the y. So we got acceleration along the y is 1, which is constant, so directly you can use the equations. Then vy is equal to uy plus ayt. Okay, so vy is equal to uy is 0 starting from rest, ay is 1, time is t, then vy is equal to t. See, even if you write down derivative or integrate, you will get the same thing. Okay, so as acceleration is constant, we have dedicated one chapter kinematics for constant acceleration, so I'm using the same thing. So now this is sy, sorry, sy is equal to uyt plus half ayt square. Okay, then displacement along the y, which is nothing but I'm taking this y coordinate because it is starting from origin, so whatever be the displacement along the y, that will be the y coordinate. You can write down if you want y minus 0 also. So uy value is 0 plus half into ay into t square, then y coordinate is, it is t square by 2. Okay, first instead of going with the first two options, I want to go with the third option first, because it's a displacement factor and D option is velocity factor. So these two things I can do, I mean we can do very easily because already we have done something related to it. Okay, so magnitude of displacement particle at time is equal to 2 seconds they are asking. Then what is the displacement at time is equal to 2 seconds. At 2 seconds the displacement vector r bar is equal to, I can write down x I cap plus y j cap, which is nothing but t cube by 3 I cap plus t square by 2 j cap. Then what is the r bar at time is equal to 2 seconds? This is 2 cube by 3 I cap plus 2 square by 2 j cap is nothing but 8 by 3 I cap plus 2 j cap. They are asking the magnitude. So magnitude of r bar is root of 8 by 3 whole square plus 2 square. You will get root 64 by 9 plus 4. Then magnitude of r bar is root of 64 plus 36 by 9. Okay, it is 100 by 9, which is nothing but 10 by 3 meter. This is the magnitude. So 10 by 3, so you will get the C option. C option is correct. Now let us go with the velocity. Velocity of the particle when it reaching the point xy. When x is 1 by 3, y is 1 by 2. Okay, so let us check. When particle is reaching the x value, at x value 1 by 3, y value 1 by 2. X value 1 by 3. That means t cube by 3 is equal to 1 by 3. So obviously it tends to time is equal to 1 second. Even if you use y value, also you need to get time value 1. T square by 2 is the y coordinate that I am using, writing as 1 by 2. Then t value 1 second. That means when particle is at 1 by 3, 1 by 2 means the time value is 1 second. So they are asking the velocity at 1 second. Okay, no? Particle is at 1 by 3, 1 by 2 means time taken is 1 second. So at time is equal to 1 second, what is the velocity? So then velocity vector I can write down as, see, Vx is t square, then t square I cap plus Vy is t j cap. Then at time is equal to 1 second is nothing but particle is at 1 by 3 and 1 by 2 position. So is nothing but it's simply I cap plus j cap. This is the velocity vector. Okay, so but they have given 2 I cap plus j cap. So that is wrong. Okay, so this is wrong. Now let us go with the torque and angular momentum. Again, see, we need to identify the whether angular momentum or torque when point is 1 by 3, 1 by 2. Already we calculated one thing for 1 by 3, 1 by 2 point. Where is the particle? Particle is at time is equal to 1 second. That means they are asking the torque at time is equal to 1 second, or they are asking the angular momentum at time is equal to 1 second simply. Okay, so that is the thing what we need to verify. So now we will go with the position and velocity vector. Okay, so then what is the position vector? I'll get xi cap yj cap, that means t cube by 3 I cap plus t square by 2 j cap. Once if you want you can verify x and y. Okay, x is t cube by 3, y is t square by 2. Okay, at time is equal to 1 second. Okay, we write down the velocity vector also. What is the velocity vector is? Velocity vector is t square I cap plus t j cap, t square I cap plus t j cap. Now at time is equal to 1 second they are asking. So if I keep time value 1 second, then I'll get position vector as 1 by 3 I cap plus 1 by 2 j cap. So see, no need to do all these things, only for better explanation I am doing all these things. But see, already position they have given, no? As they have given the position, you can write down directly position vector as 1 by 3 I cap plus 1 by 2 j cap also. So that is the way of solving. In the examination you need to think in that way. But here my explanation is towards for better understanding. So that's why I'm doing all the things. So this is not the way of solving. While you are solving, you should cut down the mathematics. Then only you will reach the answer in given time. Okay. So then velocity vector is I cap plus j cap. Then what is the angular momentum I can write down? Angular momentum I can write down m into r bar cross v bar, which is r bar cross p bar. M value is 1. R bar 1 by 3 I cap plus 1 by 2 j cap, cross product with I cap plus j cap. Then I cross I 0, then 1 by 3 I cap cross j cap, okay, plus 1 by 2 j cap cross j cap 0. So 1 by 2 j cap cross I cap. Then it will be how much? 1 by 3 I cross j k cap, and this is 1 by 2 into minus k cap j cross I. So this is 1 by 3 something like minus 1 by 2. Okay, so it will be minus 1 by 6 k cap. This is the L bar, angular momentum vector. So minus 1 by 6 k cap, yes. So B option will be correct. Now let us go with the torque condition. So again at time is equal to 1 second they are asking. So for torque we know the already force, right? So force is 2t I cap plus j cap. Then I can write down the force value as force value is equal to 2t I cap plus j cap. Then at time is equal to 1 second, what is the force value? Required force value is equal to 2 I cap plus j cap. This is the force value. And position vector we know that 1 by 3 I cap plus 1 by 2 j cap. Then I want to find out the torque from this, which is r bar cross f bar. I think from this I know that r bar has 1 by 3 I cap plus 1 by 2 j cap, and cross product with force vector is 2 I cap plus j cap. So we know that I cross I is 0, so then I cross j, so I'll get 1 by 3 I cross j k cap, okay, and 1 by 2 into 2 it will be 1, j cross I minus k cap, so you will get minus 2 by 3 k cap. This is the torque I am getting, but what is the option they have given? They have given that option which is 2 by 3 k cap. So obviously A is wrong. The correct option for this question is BC. So let us go with the next question in the section 2. The next question is saying that there is a conducting square loop of side A initially located at x is equal to 0 and moving with velocity v naught. So this is the diagram, okay. So a non-uniform magnetic field is there. It's a non-uniform magnetic field, okay. Then B naught, V naught, X naught, same thing as given, and phi X naught will tell you magnetic flux passing through loop when it is center is at X naught. So read this statement carefully, okay. Then we need to identify what is the flux value for option A and B. See, whenever you see the options like this, you can understand that you need to solve for one thing only, so that you can identify one of the option. But C option is different again, D option is different again. So maybe D option will be merged. So whenever more than one option questions comes in JEE Advanced, you need to verify whether if all the options are separate, different, that means you need to calculate 4 questions. Okay, it's not one question. So that is the thing you need to understand, and you need to plan your timing. Okay, yeah. So let us see that there is a suppose one square loop here, and center is at center position. Center of the square is at a position of x naught. Okay. Then we need to identify the flux value. So for that, magnetic field is variable. So what I am doing is I am taking the very small part in the loop at a position of x. Okay. So then the thickness of the small part I am taking as dx. Then what is the flux through small elemental area? Okay, flux through elemental area. Flux through elemental area I can write down as d phi is equal to, okay, magnetic field into area. I can write down something like an A into dx, because A is the side of the square. Okay, so A into dx will give you area of this yellow part into cos 0. So however be the magnetic field is out of the board or out of the screen, you can take the area vector also out of the screen. Then angle between the B and area vector is 0. So simply it is B A dx. But what is the B value? B value is not constant, it is variable. So I can write down B into x by x naught into A dx will be the flux through small part. Then I want to find out the total flux value, that means integral d phi. Okay, so that is B naught A by x naught, then integral x dx. Now what are the limits? That's very important. See, center position is given x naught. Then this end will stands for x naught minus a by 2. Okay, so that means this is a by 2. That's why it is x naught minus a by 2. Again this will be a by 2. Then this end will be at a position of x naught plus a by 2. That means I need to perform the integration from lower side, left side to right side. Then the integration has to be done from x naught minus a by 2 to x naught plus a by 2. So that is the way we decide. See, however you are taking the variable, according to the variable you have chosen, that integration limits will be decided. Then what is the flux value I will get? B naught a by x naught. Okay, so then this is x dx integration x square by 2. Okay, let me write down. Okay, from lower limit to upper limit. I am not writing it. So later we do it. So then I can write down B naught a by 2 x naught, x square in the place of x upper limit if I write x naught plus a by 2 whole square. Okay, and this is x naught minus a by 2 whole square. See, I am explaining each and everything so that everybody will understand. Whoever watched the video, they will understand. If you are very good at this integration technique, you can carry on your own way. Okay, so then this value goes to, okay, this value I am writing b naught a by 2 x naught multiplied with, this is a plus b whole square minus a minus b whole square. You will get 4ab, so 4x naught into a by 2, then it is 4 cancel out, even x naught also cancel out, you will get b naught a square. That is the flux value. Okay, so that means the first option will be correct, a option will be correct, obviously b option is wrong. So then this is a beautifully designed, this part. Okay, EMF induced in the loop when remains same if square loop is replaced with the circular loop of radius a by root pi. Okay, so this is the flux value, right? This is the flux value. As the what is that, loop is moving, square loop is moving, we need to first identify what is the EMF. Okay, so for that what I am doing is I am taking something like this. This is the loop. Now this loop is moving with velocity v, so that means obviously EMF will be generated over here and here. So EMF does not generate over here because these lengths are parallel to velocity. So all of you know the EMF, I think you remember the EMF values. Okay, then center is at what position? Center is at x naught position. Okay, so then what is the position of this? This position of this particular length of the or side of the square is x naught plus a by 2, and what is the position of this left side of the square is x naught minus a by 2, as we wrote previously, similar way. Then EMF will be generated in the first part, even second part also. What is the EMF generated in the first part? I can write down. So it's something like in BLV, right? So magnetic field is B naught into x value, which is x naught minus a by 2 by x naught. This is the magnetic field value. B naught x by x naught, B naught into L into V. So I can write down V. I think V value, velocity value is given V naught. Yes. So let us go with the same terminology. Okay, this is the EMF in this particular part. Okay, I will name them so that it will be easy for me to explain. So this is the EMF across the AB part. So similarly, what is the EMF across in the CD part? CD part I can write down B naught into x value is x naught plus a by 2 by x naught. Okay, A into V naught, BLV, that is the induced EMF. Okay, so obviously from the expression you can say that more EMF here, less EMF here, but what will be the thing you need to understand here is the polarity, how you are getting. See here, magnetic field is out of the plane and velocity is forward. As velocity is forward, there is a one thing called right hand palm rule. You keep the thumb in the right hand thumb in the direction of velocity, and you keep the all fingers in the magnetic field direction. Then upper side of the palm will be higher potential, lower side will be lower potential. Or else you can go with electron, force acting on electron direction. However be the electron is moving in the similar direction, you will get the negative charge. Okay, that is another way. Even this is positive and this will be negative. Whatever be the sense you are getting here, same sense you will get here also. Then what is the total EMF will be? Negative negative added, positive positive added means net EMF has to be subtracted. So it is E2 minus E1. Okay, that is the net EMF. If I am going with E2 minus E1, B naught A V naught by x naught multiplied with, okay, x naught cancel out, a by 2 minus of minus a by 2, it will be plus a by 2. That means B naught a square V naught by x naught will be the EMF when square loop is moving. Okay, if you like the efforts, okay, and the way of questions I am discussing in the channel, so please do subscribe as well as like the videos, and please comment down whatever you are thinking so that I can understand what is the need of a student, so that I can post the videos related to them. Okay, so at the same time you share these videos to in the student groups, so that will really help to channel. Okay, so don't forget this part. Okay, let us continue. Got it? Now what is the C option is saying? C option is saying that when this square loop is replaced with a circular loop of radius a by root pi, then also EMF is same. They are saying that EMF is same for circular loop also. So this was interesting when I was solving. Okay, so first I thought like as it is replaced with a square is replaced with a circle, then I thought like magnetic field will vary. Because of magnetic field variation, EMF may vary. This was my thinking, but later when I solve it, okay, now let us take a one circle, something like this. Okay, then center is at a position of x0. Okay, center is position of x0. Then if this circular loop is moving with velocity v0, then we need to identify the EMF when magnetic field is variable. What is the magnetic field value? Is b0 x by x0. Okay, so then how I am solving? Please carefully listen to this. This is very good calculation. It may useful for other questions also. Now I am choosing the very small part in the circle at an angle theta. And this is d theta. Then this elemental part length will be r into d theta. Then if I take that elemental part, okay, so if I am drawing a big diagram, then this elemental part will have the velocity v0 forward, magnetic field b will be outward. Then what is the EMF induced across elemental part? Motion EMF. EMF can be written as dl bar dot, okay, v bar cross b bar. Hope you remember or gone through this particular formula. dl bar dot v bar cross b bar. Okay, that is the EMF value. Now how the v bar cross b bar will be direction for v bar cross b bar in this case for elemental part. V bar cross b bar direction will be downward. This is the v bar cross b bar. But how the DL direction? DL direction should be along the length. That means you can take either in this direction or upward anyway. So I am taking in the downward sense. This is the DL direction. Then angle between v bar cross b bar and DL would be, this is theta. Then this is the downward sense v bar cross b bar. So this is 90 minus theta. Okay, so this angle is 90 minus theta. Then this angle will be theta. Got it? So try to understand this part. This is only the thing you need to understand, and remaining all a simple mathematics. Okay, then what is the EMF across the small part? EMF across small part I can write down as, small part is equal to, I am writing as d, which is v bar cross b bar. V bar and b bar are perpendicular to each other. Then v bar cross b bar magnitude is simply vb sine 90. Okay, vb sine 90 multiplied with length of the small part is dl multiplied with cos of angle between them, which is theta. Hope you understood. This is the v bar cross b bar magnitude, this is the dl, and dl bar dot v bar cross b bar. So the angle between dl vector and v bar cross b bar is theta, then it is dl cos theta. Okay, then what is the induced EMF is equal to v as it is. You can write down v as v0 if you want. B value I can write down b0 x by x0, okay, multiplied with dl value I can write down r d theta multiplied with cos theta again. But still there is a variable of x. What is the x stands for? X stands for x coordinate. This is the x. Then how to go for x coordinate I can write down? I can write down that if I am taking a one perpendicular here, then I will get this value is r cos theta. Then in the place of x I can write down, okay, x0 plus r cos theta. Okay, so finally what is the induced EMF in the small part? b0 v0 by x0 into r. In the place of x again, x0 plus r cos theta multiplied with cos theta d theta. Okay, hope you understood this. Yeah, so this is the EMF in the small part, but I want to find out the EMF in the entire ring. So for that I need to integrate from 0 to 2 pi. If I integrate b0 v0 r by x0 will come out. Okay, then integral 0 to 2 pi, okay, this is x0 cos theta d theta plus r will come out, integral 0 to 2 pi, okay, this will be cos square theta d theta. So I separated the integration part. Then this is b0 v0 r by x0 multiplied with, see this, if I take x0 outside, then integral cos theta will be sine theta from 0 to 2 pi plus this is r into cos square theta integration. So as we cannot perform directly, we can change it to 1 plus cos 2 theta by 2 d theta. Okay, so now sine theta, sine 2 pi 0, sine 0 also 0, so this term goes to 0. Then if I integrate this, so I think by this time you know very well about integration. Okay, as if this topic is related to second year 12th standard, I think integration you are well done. Okay, then this is 1 by 2 integral d theta is theta 0 to 2 pi plus 1 by 2 of cos 2 theta integration sine 2 theta by 2, okay, 0 to 2 pi. Then what is the value? This is 1 by 2 into 2 pi theta value plus sine 2 pi, sine 4 pi you will get 0. Again sine 0 is 0, so total term goes to 0. So then ultimately this value is pi. So I can write down this value as, okay, b naught v naught r by x naught multiplied with, okay, this is r is there and this entire integration value is pi, so I'll get pi r. So I'll get b naught v naught pi r square. This is the beautiful thing, by x naught. Okay, so what is the pi r square? Pi r square is the area of circle, okay, area of ring. That area of ring is same as area of the circular loop area will be equal to what do you say, that square loop area. Why? Because radius is a by root pi. As radius is a by root pi, you will get a square will be the what is that area of circular loop. So that means area of circular loop and area of what square loop, both are same. I'll get b naught v naught a by x naught. This is the EMF I got in the circular loop. Same is the EMF even what do you say, that in square loop. This is obviously a square, sorry. Okay, so both are same only, so that's why C option is correct. So this is really testing the patience as well as what do you say, that subject knowledge. Okay, C option. So D option, we can easily say that EMF depends on the, proportional to V bar. Okay, so then answers for this question will be ACD.